Let's have a look at question 23 in this video. So what do we have? Suppose that next to the current field there is a forest, which is also part of the village. Now the council considers to remove the forest to create a larger field that can contain more sheep. In that sense, the price of the sheep will change to this function. Now, removing the forest and creating the field could be done at zero cost. However, people also enjoy walking in the forest. The value that they attach to walking in the forest is equal to V per year, and assume also that after creating the larger field, inhabitants will decide independently between saving and buying a sheep. So if V is less than 4,000, then it is socially efficient to remove the forest and construct a larger field. Okay, so let's solve first the case if they decide to create the larger field. In that sense, we will have a different price. So we know that when the inhabitants decide independently, they maximize their own benefit. So they do so by making the marginal benefit equals to the marginal cost. And recall that the marginal benefit in this case is the price at which they can sell the sheep. So that would be 1800 minus 25s, and the marginal cost is the opportunity cost of the money, which could be 1,000 euros put in the bank, which provides 1,100 euros due to the interest rate. Now, if we solve the math over here, what do we get? Well, if we take this value to the other side, it would become 25s, and we take 1,100 to the left. 1,800 minus 1,100 would be equal to 700. So the optimal number of sheep in this case would be equal to 28. S would be equal to 28, but we only have 20 people in the village, so at most the number of sheep can be 20, meaning that S will be equal to 20. Now what's the intuition here? The idea is this: because we have a larger field, there is more grass for the sheep to eat, and because there's more grass for the sheep to eat, they can become bigger and we can sell them for more. That's why more people are willing to put them on the field. Hope this makes sense. Now with this value in mind, we can calculate the price of the sheep. What would be the price of the sheep? It would be price equals to 1,800 minus 25 multiplied with 20. So multiplied with 20. Now what would be the price in this case? It would be equal to 1,300 euros. That would be the price per one sheep. Now what would be the total value of this? So how much revenues would the citizens get? The total revenues would be equal to the price times the number of sheep, and the price would be 1,300 euros. So 1,300 euros times the number of sheep, which is 20. So times 20, and overall the value of selling the sheep would be equal to 26,000 euros. So we got that. Now let's compare this to the case if the society does not create the larger field. So if the society does not create the larger field, they will keep the forest, right? So in that case, how much value will there be? Well, because they would decide together, they will allocate the sheep and the money in the bank collectively, such that they maximize the total value of the society. And we know that in equilibrium, both the price of the sheep is going to be equal to the opportunity cost of putting the money in the bank. So all the 20 people would have a value of 1,100 euros. All 20 people would have a value of 1,100 euros, meaning that the monetary value of the society in this case would be equal to 22,000 euros. But they also have the forest, and the forest provides a utility of V, so they would also have V as an additional utility. That would be the total benefit for the society when they do not create the larger field. And we want to know in which case it's optimal to create the field, so to construct the larger field. It would be optimal when this relationship holds, that the value of creating the field, which is 26,000 euros, so the value of 26,000 euros must be greater than the value of not creating the field, which would be 22,000 euros worth for the society, plus the value from walking. Now, if we work out the math over here and we take the numbers on one side, 26,000 minus 22,000 is equal to 4,000. So 4,000 would be greater than V. 4,000 would be greater than V. In other words, V would be less than 4,000. So V would be less than 4,000. If V is less than 4,000, it is optimal to create the larger field. And the answer key tells us that if V is less than 4,000, it is socially efficient to remove the forest and construct the larger field, which is true, and we are done.